Hello, I'm Professor John Kelly, and this is the Weber Auto YouTube channel. In this episode, we are going to be looking at the 16-volt battery that comes in late model Tesla vehicles. These vehicles use a 16-volt system instead of a 12-volt system for everything except for the high voltage parts that make the vehicle move down the road. So we are going to learn where this battery is located, how it works, how it protects itself, which is a very good thing for you, and some precautions related to the 16-volt system on the vehicle, including dealing with the battery if you ever think that you need to do a jump start for it. But let's find out if your car has this battery to begin with. So to find out, we need to go inside the vehicle to the touch screen. So let's go do that next. Okay, on your touch screen, touch the car icon in the bottom left corner, and then select Software from the menu, and then select Additional Vehicle Information. In this pop-up window, if you look towards the middle, it says Low Voltage Battery Type, and it'll either say lithium-ion or lead acid. The 16-volt lithium-ion battery is located under the front trunk right here, the frunk, under this panel right here. So I'm going to lift this panel off. Okay, with the cover removed, we can see the 16-volt lithium-ion battery right here, the single electrical connector with the positive and negative terminals in it, and then we have a positive jump start terminal right here, and we have a negative jump start terminal, which is the head of a bolt right down here. So the location of this 16-volt lithium-ion battery on this Model 3 is right there. And it's in basically the same location on the Tesla Model Y that I have right over here next to us. So let's go take a look at that next. Okay, there's a few things in the owner's manual that you need to pay attention to for vehicles with the lithium-ion 16-volt battery. The first thing can be found under Jump Starting. There's a warning that says the Model Y, and the same warning is there for the Model 3, X, and S. It says the Model Y cannot be used to jump start another vehicle. Doing so can result in damage. Don't use this car to jump start another car is very important. This battery is just this tiny little thing. It was never meant to crank over a starter motor. Let's look at another important thing in the owner's manual. There's a section on the low voltage power socket in the owner's manual. And it shows you where the low voltage power sockets are and the USB ports and so on. And it says, for vehicles manufactured after approximately November of 2021, power inverters plugged into the low voltage socket must support the 16-volt DC input to function. And not just power inverters, but anything else that you plug into that power socket has to be able to support 16 volts now, because that's really close to the voltage that it runs at normally. So this is not your standard 12 to 15 volt system, so make sure your accessories are compatible. This switch to the 16-volt battery also corresponded with, as far as I can tell, decreasing the number of power sockets and increasing the number of USB sockets. So the USB sockets are voltage limited, and it doesn't matter what the source voltage is, whether it's the 12-volt battery, lead-acid battery, or a 16-volt lithium-ion battery. The USB power or voltage will be the same. All right, so that's what it says in the owner's manual about the 16-volt battery. So there's one rather humorous thing about the 16-volt lithium-ion battery I want to show you, and that's on this Model Y I have here. This is a 2022 Tesla Model Y Performance model, and its lithium-ion battery, if you look closely at that white label right there, it says it is a 12-volt lithium-ion battery, and it's not. It's a 16-volt. I don't know who made the labels or what they were thinking, but it's 16-volt. And as you can see on this photo from the Tesla Model 3 that we have over here, that's a 2023 model, and this battery that I have right here, both of these say 16 volt, And yes, I have measured the voltage of this. It is a 16 volt battery, 15 and a half, 15.6 approximately is what they run at while the vehicle is operating. So there's some mislabeled ones out there that maybe people think it's a 12 volt lithium ion battery. It's really not. It's a 16 that was somehow mislabeled for whatever reason. Okay, what are the differences between the 16 volt battery and the 12 volt battery, besides one being lithium ion and the other one being lead acid? The lithium ion battery runs at a targeted state of charge of between 75 and 85%, where the lead acid battery was somewhere between 90 and 100%. The operating voltage range for the 16 volt battery is 15.5 to 15.8, where on a lead acid battery, while charging, it could be 13.2 all the way up to 15, and with a float charger it could be 13 to 13.9 depending on the temperature. The amp hour capacity is a giant change between the two. This little tiny lithium ion battery only has a 6.9 amp hour rating compared to the 45 amp hour rating of the lead acid battery that used to be in here. But it's also much smaller, as you can see, and this thing only weighs 1.8 kilogram or 3.97 pounds versus 14 kilograms for the lead acid battery at almost 31 pounds. So it's almost 12.2 kilograms lighter or 26.9 pounds lighter. This battery has its own battery management system computer inside of it where it does cell balancing. This has 4 pouch cells in series with each other, and it has a self-protection mode where it can shut off the input and output of this battery if necessary to protect it from being overcharged or undercharged under certain conditions. The previous one did not do that. This also has a LIN data line, a communication line between the battery itself and the front voltage controller, the front computer right up here behind the battery right here that controls all the low voltage components in the front of the vehicle. It also has a push fit electrical connector. So if you look at this electrical connector right here, both the negative, this black wire here, and the positive right over there, cables come into one connector. And when you disconnect that connector, it disconnects both of them. But it's not just those two terminals like we had on the previous batteries that are there. This battery actually has 5 terminals. We have our positive and negative terminals. Then we have a single little tiny pin down inside that is our LIN data communication line. And then we have 2 other terminal pins that are right close to each other. Those are called an electronic connector position assurance clip. And that green tab that you see right there, when that is pushed down, it connects those 2 little wires of the eCPA together and lets the front voltage controller right back here know that the cable connector is plugged in and everything is good to go as far as the connection is concerned. Okay, while we are here, let's look at the jump start terminals under the frunk. The positive jump start terminal is right here. You just pull that little cover off and you've got the jump start post right there. And then the negative jump start post is this ground right here. This is where the HEPA filter that normally goes across the front here would bolt down, and you would use your jumper box on that bolt to establish your chassis ground connection. Okay, let's talk about this battery's internal self-protection mode. I told you that this has 4 lithium-ion battery pouch cells in series with each other. They run the full length of this housing here, and there are 4 of them right here. They're in series with each other, but they're laying parallel to each other. And then there's a circuit board and the connector here. And on that circuit board, there is a MOSFET transistor that Tesla calls the MOS. And the MOSFET transistor can open or close the connection to the positive and negative terminals. Positive or negative. I'm actually not sure which one it opens. And if any of you know which one it opens, or if it's both of them, let me know, because I couldn't find that information. So, right now, if we put a voltmeter on here, we should measure a voltage. So let's do that. Okay, I've got a voltmeter right here that you can see, and I'm just going to put our voltmeter, this is low voltage, 16 volts, across the two terminals, and we are reading 15.12 volts. Now, if the MOS, or the MOSFET transistor opens, we may not read anything. We might read a 0. But I also read in the Tesla service information that it could still show a voltage, but not be capable of providing current. So I haven't dared to run this one dead yet. I bought this one off of eBay. I might have to try to run it close to dead. And here are the parameters. Here's what it takes to make the MOSFET transistor open, because it's normally closed. Make it open to protect the battery from damage. If the state of charge of the battery is less than 10%, which normally would never happen, but if you drive your vehicle to where your high voltage battery state of charge gets down to 0 miles and you keep driving, you can damage this battery, because the high voltage battery is what supplies power to the DC to DC converter behind the back seat inside of a part called the power conversion system. And that power conversion system sends current to our front voltage controller here, which sends current to our our 16 volt battery here to keep it charged. So what I'm saying in a long way is, if your high voltage battery state of charge gets too low, it may not have enough power to keep the 16 volt battery charged. And if the 16 volt battery doesn't maintain a sufficient state of charge, then your touchscreen won't work, your lights, your seats, anything that would run off the low voltage system will stop working eventually. And it'll stop working as the state of charge of this battery goes from its 75 to 85% down towards 10%. So if it gets less than 10% state of charge, that MOSFET transistor is going to open and prevent it from going totally dead. And that way you don't have to buy another one of these batteries. But you need to be aware that this transistor can open to protect the battery. It may measure 0. It may not work when you plug it in, but that doesn't necessarily mean it's bad. Okay, so that's the state of charge condition, but there's more. Any of the 4 cells that have a voltage lower than 3.46, or if the entire battery pack, the 12 or the 16 volt battery pack, has a voltage less than 13.8 volts, it'll also go into protection. And that's for low voltage. And then for high voltage, any battery cell, any of the 4 cells that goes above 4.3 volts, or the entire battery pack voltage goes above 17.2, the MOSFET can open. It'll also open if the discharge current is greater than 400 amps. So if somebody hooks this vehicle up to jump start another car, which we've already determined you should not do, but if you attempted to do that and we had a rush of 400 amps, which could happen on the initial cranking, even though the steady state cranking might be less, it'll cause this battery to go open and appear to be dead. And then also charging current. So the 400 amps was current leaving the battery. Now if we have current coming back into the battery, it can't be any higher than whatever the mapped calculated value is plus 200 milliamps, a fifth of an amp. So if it's any higher than what is calculated plus a fifth of an amp, then it'll open that MOSFET. I just gave you 1, 2, 3, 4, 5, 6, 7 conditions under which this 16 volt battery can open the MOSFET transistor, either have a 0-volt reading here or have a voltage reading but appear to not have enough power to turn the car on. And you might think that the battery is bad at that point. So it isn't necessarily bad. It could be, but when it goes bad, it actually triggers an alert. VC front underscore A182 underscore replace 12-volt battery. If you get that message, it's time to replace your battery. And you might just get it during random driving. These batteries don't last forever, but this lithium-ion battery should last, I believe, a lot longer than a lead-acid battery. All right, so let's go through the recovery process. So let's pretend that this vehicle here has a 16-volt battery that has gone open. The MOSFET has opened on it. It appears dead. You're worried that you have to buy a new battery. There are 3 ways to try to make the MOSFET transistor inside the lithium-ion battery close and allow it to recover. The first way is what is shown in the Tesla Model Y and Model 3 owner's manual, and we just simply connect a jumper box, not jumper cables, jumper box to the jump start terminals. So let's go ahead and connect our positive jumper box to the positive jump start terminal and our negative to the negative. So if by chance this jumper box supplies enough current, even though the voltage is lower than it should be, to activate the contactors, the positive and negative contactors, the big switches in the high voltage battery, and they can close and turn on the DC to DC converter inside of the power conversion system, that will supply power to our front voltage controller, the computer up here in back of the 16-volt battery. And that will then communicate over the LIN bus and try to send current at the DC to DC converter provided voltage of around 15.5 to 16 volts. And hopefully that will make the MOSFET transistor inside the 16-volt battery close and accept a charge. Now, if that doesn't work, if just hooking up a jumper box doesn't cause the car to turn on, which is pretty likely because the voltage of these jumper boxes is only 12.6 to maybe 13.5 volts, then we have to do a different method of recovery. But that was the first method that's in the owner's manual. The second method is in the service manual. Okay, the second method involves disconnecting the 16-volt battery. And the first time I read that, I thought, well, how are you going to recover the 16-volt battery if it's disconnected? Well, it took me some reading to figure it out, but let's do it. Let's go ahead and disconnect the 16-volt battery. We're going to lift up on the electronic CPA clip and then pull towards the driver's side on the black electrical connector while lifting up on the gray connector at the same time. And now our 16-volt lithium-ion battery is disconnected. Now, with it disconnected, it's out of the circuit totally. And now the next step is to hook our jumper box up to the jump start terminals. So go ahead and hook those up again. Okay, now with this jumper box hooked up and the 16-volt battery disconnected, we're to try to turn on the vehicle. So go ahead and open the driver's door, hit the brake pedal. Let's power up the vehicle. There we go. Headlights are on. We're powered up. And what that means is that our jumper box is substituting for the 16-volt battery, and it has turned on the contactors. It's provided enough power to turn on the contactors in the high voltage battery. DC to DC converter works, front controllers trying to provide voltage and current to the 16-volt battery, but it is disconnected. So while the car is on and we know that the system is powered up, now we plug back in the 16-volt low voltage battery connector. So go ahead and plug that back in. To plug it in, you line it up, push it down, and push in on the black You got to push down first. It's kind of together. There we go. And then the green connector position assurance clip. Now by doing that, the DC to DC converter output is already at the 15.5 to 16 volts. And that by itself might allow the battery management system, the low voltage battery management system inside the battery, to turn back on the MOSFET transistor and allow this battery to charge. So our next step then is to disconnect the jumper cables and hit the brake pedal one more time. Okay, good. So I've shown you the owner's manual method of just using a jumper box and hoping that the contactors will close. If they don't close, then we do a special procedure of disconnecting the 16 volt battery and then hooking the jumper box up. So the third method of trying to get the battery to recover is to do what we did in the second method. We do the exact same steps, but then we go into the Toolbox 3 software from Tesla, and there is an action called Low Voltage BMS Reconnect LV Battery. And we'll run that action, and that, I believe, sends a command over the LIN bus to the BMS inside the low voltage battery to close the MOSFET. If that doesn't work, then I think you're out of luck. You're going to have to buy another battery. There's a new button in service mode for the low voltage battery called Reconnect Low Voltage Battery. Now, that may or may not be the same thing as this scan tool procedure that I just showed you, but I think it might be. I just don't know for sure. If any of you out there know, I can't find any documentation that says it is, but I'm leaning towards that it is the same command. Okay, there's a lot of Teslas out there with this 16 volt battery. As I mentioned, some might be mislabeled as 12 volt, but they're really 16. There's some special service procedures and special precautions you need to take when working around this battery. This battery is part of a very unique low voltage architecture system that I hope to do a video on in the future. But for now, we've covered the basics of this 16 volt lithium ion battery and jump starting and recovery. So if you liked this video, please subscribe to the Weber Auto YouTube channel. Click that bell to be notified when new videos come out. Also, if you feel so inclined, please donate to our automotive department here at Weber State University. There is a donation link in the video text description down below. We also offer a fantastic education in electric vehicle and hybrid technology here at Weber State University for regular college students. And we also offer training to anyone in the world that you do not have to be a Weber State automotive student. We have 2 online courses, a high voltage safety course and a high voltage systems course. And then once you've done those 2, you can come and do a 5-day hybrid and electric vehicle boot camp where you spend 5 days here with me in the shop getting your hands on up to 15 different high voltage vehicles, 8 different battery electric vehicles, 2 plug-in hybrids, and 5 regular hybrids, and learn how these systems work, how to do a little diagnosis and repair work on them, and maintenance work. All right, that's it for today. Thank you, and have a good week.